Welcome to Study Loop.
So let's think about effective nuclear charge. And effective nuclear charge, which is sometimes written ZEFF, is calculated by taking the difference between Z and S. Z is the number of protons that an atom has, and S is the number of shielding electrons. And those shielding electrons are the core electrons. Core meaning not the valence or outer shell electrons, all the ones in the inner shells, when we sum them up. So for example, if we were to take a look at potassium and we were to think about the nucleus and the shells of potassium, we would have the nucleus down here, and the first shell would hold 2 electrons. The next shell holds 8 electrons. The next one has 8. And for potassium then, it ends with 1 lone electron in the last shell, in that 4th shell. So when we're doing our calculations, we need our number of protons. So potassium is number 19 on the periodic table, so the nucleus has 19 protons. Minus the shielding electrons. So the shielding electrons are going to again be the core electrons, the ones that are not valence. And we add them up. 8 plus 8 plus 2 is 18. And so when we subtract, the effective nuclear charge for potassium is 1. And we can do this with some other ones. We can go and take a look, for instance, at calcium. And if we were to do the same thing, we have our nucleus. Calcium has 20 protons in it. And the way that we would have our electrons configured is 2 in the first shell, 8 in the second shell, 8 in the third shell, 2 in the fourth shell. So when we go and we do our math, we're going to have our 20 protons. Now, how many are core or shielding? Well, in this case, it's the same number as the number in potassium, 2 plus 8 plus 8, or 18, giving the effective nuclear charge of calcium as 2. Now, if we were to do this for oxygen, we could go ahead and do the same thing. We're going to have our nucleus. Now, there's going to be fewer shells here. First one holds 2. Now, the second one can hold 8, but there's only 6 in there because oxygen has a total of 8 protons and 8 electrons. So our Z, our number of protons, is 8, minus our shielding electrons, only 2. Those are our core. So we are left with an effective nuclear charge of 6. And finally, sorry, that was part C. Finally, if we were to do this for carbon, we would have our nucleus, 2 and 4. 2 shells, first one holds 2, second one holds 4 because there's only 6 protons for carbon. So 6 minus, shielding is still only 2. And so we're going to get an effective nuclear charge of 4.